Hello, and welcome to exercise 29, practice drawing ellipses and polygons. This particular exercise doesn't have an auxiliary model. However, we will be using a template, and that template is small objects, millimeters. So go ahead and get that template open, and we'll be ready to get started. Okay, so the first thing we're going to do is draw a rectangle from diagonal corners. So from the curve menu, click rectangle, and then click corner to corner. For the first corner, we're going to actually type in some coordinates into the command bar, and those coordinates are going to be -10, -5. Enter. For the length, type 20 and then press enter. And for the width, type 10 and then press enter. The next thing we're going to do is draw rectangles from a center point with length and width and rounded corners this time. So let's go ahead and get started. From the curve menu, click rectangle and then click center corner. Curve, rectangle, center corner. Now keep in mind we will be ultimately drawing 3 rectangles and they will all have the same center, which will be 0, right? So having said that, keep in mind also that the next 2 rectangles that we will be drawing are going to have rounded corners. So please be sure to hover your cursor over to the command bar and click the rounded option. There we go. Now we're ready to begin. So the center once again is 0. The length is going to be 19. The width is going to be 9. And the corner radiuses are going to be 1. All right, moving on. Now we're going to repeat these steps for a second rounded rectangle with slightly different dimensions. So right-click to bring up the previously used command. Make sure to click rounded in the command bar. We have the exact same center, which is 0. Press enter. And this time, the length is going to be 18, and then press enter. The width is going to be 8, and then press enter. And the new radius is going to be 0.5, enter. The next thing we're going to do is draw an ellipse from its center and axis ends. So we're going to go to the curve menu and click ellipse, and then click from center. For the ellipse center, type 0 and press enter. For the end of first axis, type 4 and press enter. Make sure that ortho is on and pick a point to the right and click one time with your left mouse button. All right. Now for the end of second axis, type 2.5 and press enter. Toggle your cursor in the correct direction and pick a point, and that completes that part of the exercise. Moving on, now we're going to draw 4 different polygons, each that corresponds to each one of these quadrants within the Rhino interface. And we're going to be drawing a pentagon, a triangle, a hexagon, and an octagon. So let's go ahead and get started with the octagon. No, actually, let's start with the smaller number of sides and slowly work our way up. Let's go ahead and get started with the triangle. So from the curve menu, click polygon, center, radius. Then click number of sides. It's already set to 3, so I'm good to go. Now it wants to know the center, right? In this case, the center is going to be a set of coordinates, which are going to be -7, -2. Press enter. And for the corner of the polygon, type 1.5 and then press enter. Toggle your cursor to orient the triangle in the correct direction, this being in the correct direction, and then click one time with your left mouse button to finalize the placement of the triangle. Okay, moving on. Now we're going to draw the pentagon, which is located directly above the triangle. And keep in mind, since we are working with a Cartesian grid, we have very kind of symmetrical numbers to work with. So it's easy to kind of do just some simple math to figure out the center of the remaining polygons. So next we're working on the Pentagon. So let's right click to bring up the previous command. And once again, it's asking us for the center of the inscribed polygon. So let's take a few steps backwards. So we know for a fact that the center of the triangle was -7, -2. Ergo, the center of the pentagon is going to be -7, +2, right? Okay, so we know those coordinates. Now let's make sure we have the correct number of sides set up in the command bar. Right now it's set to 3, so let's click that and go ahead and change that to 5. Now let's go ahead and input those coordinates that we figured out. That was -7, 2. Enter. Corner of polygon is basically, it's going to be the same for all 4 of these polygons, which is going to be 1.5. Enter. Toggle your cursor so that the pentagon is oriented in the correct direction, and then click one time with the left mouse button to finalize the placement. Okay, moving on. Now we're going to draw the hexagon, which will be located approximately in this portion of the quadrant. Let's go ahead and get started. Let's go to Curve, Polygon, Center Radius. We know that a hexagon has 6 sides, so let's go ahead and change the number of sides to 6 and press Enter. And now again, let's do a little bit of basic math to figure out the center of this particular inscribed polygon. We know the center over here was -7, +2. So ergo, over here, the center of this polygon is going to be +7, +2. So let's go ahead and type in those coordinates and then press Enter. For the corner of polygon, type 1.5 and press Enter. Toggle your cursor like so, and then click one time with the left mouse button to finalize the placement of the polygon. The last polygon that we're going to address is the octagon. So one more time, right click to bring up the last previously used command. And this time we're going to have an octagon with 8 sides. So let's go ahead and change that and press Enter. Again, using some basic math, we can determine that the center of this polygon is going to be 7, -2. So let's go ahead and input those coordinates. And the corner of the polygon is going to be 1.5. Enter. Now, it seems to be acting a little strange. It seems not to want to toggle in the correct direction. And this is an easy solution, and that one being moving your cursor over to the mode and clicking one time to change it from inscribed to circumscribed. Now you'll see it can easily be oriented in the correct location. Now we need to input one more time the midpoint of the polygon edge, which is 1.5, and then press Enter. Make sure you toggle one last time straight up. Make sure it's going in the correct direction, and then you can click one time with the left mouse button to finalize the placement of the octagon. Okay, that basically concludes the two-dimensional portion of this exercise. Next, we're going to make the rounded rectangles solid. Select the larger and smaller rounded rectangle. Now, we really won't be able to see what's going on by viewing this solely in top view, so now would be a good time to go back to our 4 viewports so we can see just exactly how everything is transforming in 3 dimensions. Okay? So, once again, select the larger and the smaller rounded rectangle, like so. Now, from the solid menu, click Extrude Planar Curve, and then click Straight. Solid, Extrude Planar Curve, Straight. Drag both down to set the thickness and click or type a value for the thickness. Use a negative number to extrude downwards. So I'm going to go ahead and extrude downwards and click right around here. There we go. Now it might not look quite as 3D as you would hoped it would, and that's probably because we're looking at it in wireframe in our perspective viewport, which is an easy solution. If you click on the drag down menu, you can change your viewport style to shaded, and you'll see it has much more three-dimensional properties. And keep in mind, the two rounded rectangles are coplanar. In other words, they're in the same plane. Because of this, the smaller rounded rectangle is removed from the larger one, and the difference has been extruded. Now let's make the rectangle solid. Let's go ahead and select the rectangle. From the solid menu, click Extrude Planar Curve, and then click Straight. Set the both sides option to no. In my case, it's currently set to no, so I'm good to go. If yours reads both sides equals yes, just click it and it automatically changes to both sides equals no. Drag it up to set the thickness and click. I'm going to zoom in a little bit and orbit a little bit so I get a thickness I'm happy with, and then I'm going to click. Alright, there we go. I'm going to click away from all the objects so I can clear my selections. Now I'm going to make the ellipse solid. So to do this, I'm going to do this from the perspective viewport. However, as you can see, you can't really see the ellipse anymore. It's still there, right? As you can see in the top view. And once it's selected, you can see it in the perspective view, but I'm having a hard time seeing any of these polygons and the ellipse in shaded view. So before I move on, I'm going to change my viewport style to ghosted. There we go. Now I can see the solids and the wireframes. Now I'm going to select the ellipse. And from the solid menu, I'm going to click Extrude Planar Curve. Solid, Extrude Planar Curve, and then click Straight. Now I'm going to set both sides option to yes by just clicking on it one time. Pick to set the thickness. Make sure the thickness is enough to protrude through both sides of the rectangular solid. So I'm going to orbit just a little bit to make sure it actually does go through both sides of the solid, like so. There we go. Now, to extrude the polygons, select the polygons. Remember, you can do this using Shift. There we go. And from the solid menu, click Extrude Planar Curve. And then click Straight. And then pick to set a thickness. Now, to cut holes with the solid polygons, select the rectangular solid. So I'm going to clear my selection by clicking away from everything. And now I'm going to select the rectangular solid. And now from the solid menu, I'm going to click Difference. Solid, Difference. On the command line, click Delete Input. make sure it is set to delete input equals no, like so. For the second set of surfaces or polysurfaces, select solid polygons and press enter. So now I'm going to select these guys and press enter. Holes will be cut, but the objects will remain, and that might not be so obvious. However, if I were to say Windows select these polygons and move them slightly in one of my parallel views, you can see what has happened in the perspective viewport, and maybe even better so if I change this to say rendered. There we go. Alright, we did it. And that concludes exercise 29.